Have you ever wondered why grocery store shelves remain stocked day after day? Have you considered how many interconnected systems are working behind that convenience? If transportation paused for only 3 days, what would change? How many crops truly feed most of the global population? If more than half of global calories come from only 3 staple crops, is that concentration truly resilient? When energy prices rise, how does fertilizer production respond? And when fertilizer becomes more expensive, does the pressure fall first on farmers or consumers? Does maximum efficiency automatically create long-term stability? Are we confusing convenience with durability? Modern food systems are largely built on minimal inventory models. Many retail locations maintain only a short supply if transportation is interrupted. Synthetic nitrogen fertilizer production relies heavily on fossil energy sources. When energy markets fluctuate, agricultural input costs tend to fluctuate as well. These observations are not meant to cause alarm. They help clarify how a highly optimized system functions. Efficiency has allowed agriculture to feed billions of people. It has reduced costs and increased productivity. Yet, optimization often reduces redundancy. When conditions are predictable, such systems perform exceptionally well. When weather patterns shift, energy markets change, or logistics slow down, adaptability becomes more valuable than speed alone. This leads to a broader perspective. If the objective extends beyond seasonal yield toward multi-year stability, the design of a garden may need to evolve. Imagine a landscape where crops do not require replanting every season. Picture soil that grows richer over time because root systems deepen with each passing year. Consider plants that fix nitrogen from the air, gradually enhancing soil fertility without external inputs. In natural ecosystems, most vegetation is perennial. These plants persist across cycles and contribute to ecological balance. Applying that principle at home means building a foundation rather than chasing short-term output. Annual crops provide flexibility and rapid harvests. Perennials provide continuity and depth. Deep roots improve water retention and reduce erosion while strengthening soil structure. Once established, many perennial crops continue producing for years without replanting. This approach does not eliminate annual gardening. It adds structural stability to it. 10 perennial crops will be explored based on nutritional value, regenerative capacity, and low maintenance once established. The intention is to develop a balanced home food system where efficiency and resilience support one another within a thoughtful design. Looking more closely at the structure of a garden, the difference between annual and perennial crops goes beyond lifespan. It lies in how each interacts with the soil. Annual plants complete their life cycle within a single growing season. They germinate, grow flower produce seed, and then decline. To maintain production, gardeners must replant each year, often disturbing the soil and sometimes adding fertilizers to replace nutrients that were removed. This approach provides speed and flexibility, yet it also creates a recurring dependence on external inputs. Perennials operate differently. Instead of starting from seed every season, they maintain their root systems and biological structure for many years. The root systems of many perennial plants extend far deeper than those of annual crops. Deeper roots allow access to moisture stored below the surface, improving drought tolerance. At the same time, strong root networks anchor soil in place, reducing erosion and protecting valuable topsoil. As older roots decompose, they contribute organic matter, gradually enhancing soil structure and natural water retention. Another significant advantage involves nutrient regeneration. Certain perennial legumes form symbiotic relationships with soil bacteria that fix nitrogen from the atmosphere into the soil. This natural process increases fertility without relying solely on synthetic fertilizers. Because synthetic nitrogen production depends heavily on fossil energy, fluctuations in energy markets can influence fertilizer costs. Integrating nitrogen-fixing perennials into a garden design reduces vulnerability to those shifts while strengthening long-term soil health. Perennials also reduce the need for repeated tilling. Frequent soil disturbance can disrupt beneficial microbial communities and weaken soil structure. When soil remains relatively undisturbed, microbial ecosystems stabilize and support nutrient cycling more effectively. Over time, a garden dominated by perennials begins to resemble a small ecosystem where plants, roots, and soil organisms interact in a balanced way rather than functioning as isolated components. Self-regeneration is another defining feature. Many perennial crops reproduce through roots, tubers, or divisions instead of relying solely on new seeds each year. Once established, they return season after season with less labor than during their initial planting phase. This continuity supports gardeners seeking to create reliable food sources without repeating the same level of input annually. The biological differences between annuals and perennials are not meant to rank one above the other. Each has a role. When combined thoughtfully, they create a garden that balances flexibility with durability. Understanding these structural advantages provides a clear foundation for selecting specific perennial crops that align with the goal of building a food system designed to endure and improve over time. With a clear understanding of the biological advantages of perennials, the next step is identifying crops that can serve as the caloric and protein foundation of a home garden. A resilient food system requires more than leafy greens. It needs reliable energy sources and adequate protein to support long-term health. 3 perennial crops stand out in this category: Siberian pea shrub, Jerusalem artichoke, and American groundnut. Siberian pea shrub is a hardy leguminous shrub known for its cold tolerance. Its seeds can contain around 30% protein by dry weight. Beyond nutritional value, this plant fixes nitrogen, enriching the surrounding soil over time. When planted as a hedge or windbreak, it provides food while also contributing structural protection to the garden. Once established, it can produce seeds for decades. Seeds should be cooked thoroughly before consumption to ensure proper digestion. Jerusalem artichoke, often called sunchoke, is a tuber-producing perennial that offers substantial caloric output. Mature plantings can yield significant harvests per square meter. The tubers contain approximately 73 calories per 100 grams and can remain stored in the ground throughout winter. This characteristic effectively turns the soil into natural storage, reducing reliance on external preservation methods. The plant tolerates poor soils and moderate drought conditions. However, because it spreads vigorously, thoughtful placement and management are recommended. American groundnut is a native North American vine that produces protein-rich tubers containing roughly 15 to 17% protein by dry weight. Compared to many other root crops, this is a notable level of protein. As a legume, it also fixes nitrogen, contributing to soil regeneration. The tubers have a mild, nutty flavor and can be prepared in ways similar to potatoes. The plant thrives in moist soils and allows harvest at the end of the growing season while leaving part of the tuber network intact for regeneration. Together, these 3 crops form a diversified foundation. One functions as a long-lived shrub producing high-protein seeds. One supplies calorie-dense tubers with natural in-ground storage. One provides both protein and soil improvement through nitrogen fixation. This diversity reduces dependence on a single food source and increases long-term stability. Selecting foundational crops depends on climate, available space, and household goals. When integrated thoughtfully, these perennials not only provide food, but also strengthen the ecological structure of the garden, creating a stable base upon which nutrient-rich greens and supportive plants can thrive in balance. Alongside calories and protein, a resilient food system must be supported by essential micronutrients. In many situations, fresh greens are among the first foods to become scarce when supply chains are disrupted. Vitamins A, C, and K, along with folate, calcium, and iron, play vital roles in immune function, bone health, and overall metabolism. Building a layer of perennial greens within a home garden is therefore a strategic step toward maintaining nutritional balance over time. Perennial kale, including varieties such as tree collards, stands out as a reliable option. Unlike annual kale that completes its cycle within one season, perennial forms can continue producing for several years. When grown in suitable climates, they offer a steady harvest of leaves without the need for yearly replanting. Kale is known for its high vitamin C content, often exceeding daily recommended amounts in a modest serving. It also provides vitamin K and antioxidant compounds that support overall health. As a perennial, it becomes a dependable source of fresh greens integrated into the garden structure. Good King Henry is a lesser-known perennial green with a long history of use in Europe. Its leaves can be harvested for several months from early spring through late autumn without bolting as quickly as many annual greens. Nutritionally, it supplies vitamins A and C as well as minerals such as iron and calcium. Young shoots can be prepared similarly to asparagus, expanding culinary options within a single plant. Its cold tolerance makes it suitable for a wide range of growing conditions. Asparagus represents one of the longest-lived perennial vegetables. Once established, it can produce for 20 years or more. Asparagus is rich in folate, vitamin C, and antioxidant compounds. One of its most valuable traits is early emergence in spring, when many other vegetables are not yet available. This timing provides an important nutritional bridge between winter storage foods and the new growing season. Together, these three perennial greens create a staggered supply of micronutrients. One offers extended leaf production, one stretches the harvest window across multiple months, and one delivers fresh produce at the very start of the season. This distribution across time reduces nutritional gaps and enhances dietary stability. Perennial greens are not merely supplementary crops. They complete the nutritional structure of a home food system. When thoughtfully combined with calorie and protein-producing perennials, they create a balanced framework that supports both immediate nourishment and long-term health within a sustainable garden design. With calorie crops, protein sources, and perennial greens in place, a resilient home food system benefits from an additional layer of multifunctional plants. These crops not only provide nourishment, but also enhance soil quality support, microbial life, and enrich everyday meals. Rhubarb chives. Egyptian walking onion and sea kale represent this supportive category. Rhubarb is often associated with desserts, yet its value extends far beyond that role. It is highly cold tolerant and can persist for many years once established. A mature plant can produce a substantial harvest annually. The stalks contain vitamin K and antioxidant compounds. The large leaves, while not edible, serve an important function. When placed around other plants, they decompose quickly and form a natural mulch layer that conserves moisture and suppresses weeds. In this way, rhubarb contributes both food and organic material that strengthens soil structure. Chives are a small perennial allium with a significant impact. They grow in dense clumps and return year after year with minimal care. Their leaves contain natural sulfur compounds that contribute to overall health. In a simplified food system, flavor becomes increasingly important for maintaining appetite and morale. Chives add a mild onion taste that enhances a wide range of dishes without requiring much garden space. Egyptian walking onion offers a remarkable example of self-propagation. Instead of relying solely on seeds, the plant forms small bulb clusters at the top of its stalk. As these bulblets mature and bend toward the ground, they can root and establish new plants. Over time, this process creates a stable and expanding onion patch. The plant tolerates cold conditions and provides both green stalks and small bulbs for culinary use. Its regenerative habit reduces the need for purchasing new planting material. Sea kale is another adaptable perennial capable of thriving in poor soils and even tolerating mild salinity. It produces multiple edible parts throughout the growing season, including young shoots, leaves, and flower buds. Its resilience allows food production in areas where other crops may struggle, broadening the productive capacity of the garden. Together, these multifunctional plants act as connectors within the system. They enrich soil, diversify flavors, and increase ecological stability. Their presence enhances flexibility while preserving dietary variety. When nutritional and ecological elements work in harmony, the home food system becomes not only sufficient, but also balanced and sustainable over the long term. Once the foundational crops have been identified, the next consideration is not simply what to plant, but how to implement them in a way that supports long-term success. Building a food system based on perennials requires thinking in multi-year cycles rather than single seasons. A practical approach can be visualized as a 3-year pathway where each stage plays a distinct yet connected role. The first year is the establishment phase. This is the time to select appropriate locations for each crop group. Protein and calorie-producing plants such as Siberian pea shrub, Jerusalem, artichoke, and American groundnut should be placed where they have sufficient space to expand over time. Perennial greens benefit from locations that allow easy and regular harvesting. During this phase, the goal is not maximum yield, but strong root development. Applying organic mulch and minimizing soil disturbance supports early stabilization. The second year becomes a period of consolidation. Root systems extend deeper and spread wider. Some crops may offer modest harvests, yet observation is more valuable than volume. Gardeners can assess how each plant adapts to local conditions and make adjustments to spacing, or add complementary species if necessary. Biodiversity increases as plants provide shade, retain moisture, and gradually improve soil structure. By the third year, the system begins to show greater stability. Many perennials enter consistent production cycles. The benefits of continuity become visible. Crops no longer require annual replanting, soil disturbance decreases, and external inputs can be reduced. At this stage, integrating selected annual crops alongside perennials creates balance. Annuals offer flexibility and experimentation, while perennials provide structural reliability. Thoughtful land allocation strengthens the overall design. A portion dedicated to calorie and protein crops. A portion reserved for nutrient-dense greens. A smaller area for multifunctional and flavor-enhancing plants. This balanced distribution prevents over-reliance on any single category. Looking ahead, a mature garden represents more than food production. It becomes an integrated ecological space where roots, soil, and plants support one another. Confidence grows from early preparation and steady progress. Starting small and adjusting gradually often proves more sustainable than attempting rapid expansion. A home food system does not need to be perfect from the beginning. What matters most is long-term direction and patience. As the first perennials take root and return season after season, stability becomes a natural and reassuring presence in daily life.